Good evening, everyone. A warm welcome to our F1 Data Scientist Internship Hackathon launch event today. Today, we are going to explain you how to participate in this event, what will be the procedure, and how we'll assess the internship applicants and so on. And the host for today's session is going to be Jayendra Vadrevu. We call him Jay. Jay is the founder and chief architect of Cluzters.ai platform. He has more than 13 years of work ex in IT industry. He worked as a data science consultant for Fortune 500 clients before, and he's going to explain you the whole process of this internship hackathon as well as about the Cluzters.ai platform and how to participate. We will get started soon. Jay, you can get started whenever you are ready.
Thank you, Pradeep. So participants, can you please give me a yes if you are able to hear me and see my screen? Okay, great. So let me get started now. So I'll begin with giving you all a quick introduction to Cluzters.ai. So we are a deep tech platform and we have a vision of democratizing AI through model crowdsourcing. So we are a deep tech club startup, NASSCOM deep tech club startup, which is among the top 7% of the deep technology companies in the country. We have represented Telangana State in Raise AI 2020, which is a global AI summit. And we've also won a national award from Government of India for providing AI solutions for better governance. So we've also featured as part of NASSCOM Emerge 50 startups. And this is our leadership team. So I'm Jayendra Vadrevu. I'm the founder. I have more than 13 years of work experience in data science, management consulting, and AI space. And I'm an ISB alumni. So I have an experience of consulting with Fortune 500 companies. And also I have with me my co-founder, Pradeep Marupati. So he has more than 13 years of work ex in business analytics, data engineering space. So he's an alumnus of Kelley School of Business, US. And we also have Uma, who is the product owner. So he has over 12 years of work experience in the project management space. He has predominantly worked in the SaaS area. And we have Raji Reddy. So he has strong applied AI research experience and cloud experience. And he is currently working with us as a senior data scientist. And our advisory board consists of Raghuram Shamabat, who is the head of AI Cognizant Business Consulting Asian Markets. And we also have Vasant Rao, who is the director of IDC India Limited. So this is the leadership team. And let me start introducing the platform to you. So we are a first of the kind deep tech platform, which is focused towards
Sorry to interrupt. I think slides are not moving for us. We are still on the first slide.
Okay. Let me just check. I'm going to stop and start this screen sharing again. Do let me know if you're able to see my screen. Yep. Are you able to see the screen now?
Yes.
Okay, great. Yep. So I've already given you an introduction to the team here. So I'm the founder, Jayendra Vadrevu, and Pradeep is the co-founder. Uma is the product owner. Raj is a senior data scientist, and I've also introduced you to our advisory board. Now let me introduce you to the platform. So Cluzters.ai, right? So we are a first of a kind deep tech platform, which is focused towards data scientists, AI startups, and domain experts. So the whole intent of the platform is to crowdsource quality machine learning models across various verticals like banking, healthcare, pharma, so on and so forth. And we are targeting to go ahead and get all the participants in the AI industry, that is data scientists, corporates, startups, everyone onto the same platform where they can join hands and they can create AI solutions, deploy AI solutions, and going forward also monetize on AI solutions. So that is how Cluzters as a platform has been built. So now let me go ahead and do a deep dive with respect to what can you do on clusters as a data scientist or a data science enthusiast. So what are the features that are available on clusters? So on clusters, there are three main imperatives that we work with. The first one is we facilitate collaboration and networking on the platform. So this is where we have data scientists coming together, sharing knowledge with each other, and also trying to learn from each other's expertise. So that is where we have vertical and horizontal structures. That is, cluster is typically a group of like-minded data scientists on the platform. So we have vertical clusters as well as horizontal clusters. Vertical clusters are more in terms of industries, that is banking, retail, healthcare, etc. And horizontal clusters are more in terms of technologies like computer vision, NLP, structured data predictions, etc. Now, once you join the platform, you can either be part of vertical clusters or horizontal clusters or both. And you can be part of mini clusters also. That's up to you. That whatever clusters interest you, you need to join that. So what happens when you join these clusters? So the moment you join vertical and horizontal clusters, you are given access to a lot of curated content in these spaces. For example, if you join banking cluster, you would be given a lot of content in the form of videos, news articles, research reports, ebooks, data sets, codes, so on and so forth. You'll have a lot of knowledge with respect to banking industry and in the context of AI. So the entire platform works in the context of AI, artificial intelligence and machine learning. And once you join each of these clusters, you will see a lot of content that is relevant for that particular space. And not only that, you also get to interact with fellow data scientists who are like-minded and are interested in the similar kind of subjects. So that is what is first imperative, clusters. Now, let me go ahead and show you what can you do on the platform quickly. So for that, I'll be taking you to the platform. So the moment you sign up on the platform, this is how your home screen will look like. Here, these are the clusters that I talked about, which are all the vertical clusters first, followed by the horizontal clusters. Whichever interests you, right? You can go ahead and click on that, and you can go ahead and sign up for that particular cluster. For example, this is the banking cluster. So in the banking cluster, there are people already who are part of this, who start discussing about various things in the banking and AI space. Okay, and this is where you have various features for networking and collaboration. For example, you can start your own discussions. So there are data scientists who start discussing about various things in the banking industry, in the AI space, and fellow data scientists can go ahead and add on to your discussions. There is Vault, where there is a lot of content with respect to codes, ebooks, data sets that are available for you to explore in the banking and AI space. And then you have videos. So we have all the curated videos. Again, this is community curated videos on banking and AI space. And this is a lot of knowledge content that you can imbibe. And similarly, we also have curated jobs that are available in this particular space. And we also have courses which are there in this particular space. Okay, so again, this entire cluster focuses on banking and finance in the context of AI. Similarly, you can join any of the clusters that we have talked about here, and you can start collaborating and you can start assimilating knowledge from these clusters. So that is the first imperative of the platform, to impart as much knowledge as possible to all the data scientists so that you can create quality machine learning solutions. Now, left-hand side, whatever you're seeing on the home screen are the various features that we provide on the platform through which you can grow your knowledge. So you have already seen clusters. So that's the first one. Followed by this feature where you can follow the data scientists. So let's say you would want to follow data scientists. You can come here. There are a lot of data scientists who are on the platform. So you can go ahead and follow the data scientists. And whenever they deploy a model, or whenever they write an article, or whenever they curate a video, that feed comes to your profile. So that's how you can actually keep in touch with fellow data scientists. So that's a following the data scientists. Then we have Model Hub. This is the core heart of the platform. That is where all the machine learning models are deployed. So I'll talk about Model Hub in much more greater detail moving forward. So I'll skip for it now because this is the whole point of today's webinar, the Model Hub, where the research and model building exercises are taken up. So that is something that I will talk about going forward. So let's move to the next one. We have data and code sharing. So if you go ahead and click on this, you will be immediately taken to this particular page where you have a lot of code files, data sets, ebooks, and other documents that you can access for free. And guys, these are curated, especially in the AI space. So we have more than 1,000 collateral available in this space that spans across code files, data files, ebooks, etc. Then we also have jobs here. If you click on this, you will be taken to the jobs section. So this is where you see curated jobs, and you can also go ahead and apply for jobs whichever interests you. And then we have what's hot. As part of what's hot, you will see that we have linked more than 500 different news feeds across the open web to clusters, where whatever happens in the AI industry, that news article gets automatically published on clusters, and you can find all those news articles here. So currently we have more than 50,000 news articles which are already curated in the AI space. So you can explore that as well. Then we have video library, where you can either create your own channels, video channels, as you do it on YouTube, or else you can view the channels and videos that are uploaded by your fellow data scientists. So if you go ahead and look at this, this is how it looks like. So these are all the latest videos that are available on clusters. You can browse channels. You can go ahead and look at various videos that are available. So this is again in the context of knowledge building. That is, you can go ahead and watch various videos. You can search for videos that interest you. So we have a lot of videos that we have already curated on the platform. You can access all these videos which are curated in the data science and AI context. So this is also going to add a lot of value to your knowledge. Next, we have Q&A, where you can participate in a forum kind of an environment, where you can get into these forums. You can ask questions, answer to the existing questions. If you are already an expert, you can answer existing questions, and you can interact with other fellow data scientists and get your doubts clarified. So that is what is a clusters Q&A forum. Finally, we also have concept articles that are again created by fellow data scientists. So if you go to the articles, you will see that there are a lot of articles that pertain to very specific topics in the data science and AI space that you can refer to in order to understand how various aspects in the data science and AI world work. It could be with respect to algorithms. It could be with respect to how projects are executed. Anyone can write a knowledge article here. So that is how knowledge articles can also be used to augment your existing knowledge. So guys, if you observe all the features that we have provided on the platform, these features would help you to grow your knowledge in the data science and AI space. And it's absolutely free for all kind of a community. Anyone can join this community and contribute to it. And at the same time, also imbibe the content that is there on the platform to grow your data science and AI knowledge. Let it be with respect to verticals like banking, insurance, etc. Or if you are interested in pursuing any horizontal specialization like computer vision, natural language processing, you can do that as well. So how to use the platform is completely up to you guys in order to go ahead and improve your knowledge on the platform. So that's the first imperative that we wanted to cover here. That is facilitating collaboration and networking on the platform. So the second imperative is we have already sourced some data sets on clusters, and we also are procuring certain proprietary data sets for, again, that will be only limited to the top data scientists on the platform. So we will open those data sets only to the top data scientists who can actually access those proprietary data sets and create a machine learning solutions. That's the data sets part. And the third and the most important imperative on the platform that makes clusters truly different from any other data science and AI platforms out there in the open web is we enable model crowdsourcing and deployment. So this is the first of its kind platform in the world where data scientists can go ahead and deploy their machine learning solutions, and that too free of cost, without having to pay anything, without having to maintain the infrastructure or servers or anything. So on our end, what we do is we have a flexi inference framework that we have built that is capable of deploying hundreds and hundreds of machine learning models parallelly. So how is this different from current sharing platforms like GitHub? So if you look at the current sharing platforms like GitHub, right? So what happens is a data scientist typically shares his or her model on GitHub, and someone else either forks that repository or looks at that particular model and tries to improve on top of it. But again, for someone to go ahead and see how the model is working live in action, they would have to recreate the same exact environment that the data scientist has created and host it as an API, and then go ahead and access that particular solution. So that is the deployment part. And that's the most difficult part in the data science and AI world, where a lot of infrastructure is involved. Because high-end GPUs and CPUs needs to be involved for you to deploy your machine learning solutions at scale. So for those reasons, Cluzters.ai now makes it easy for the data scientists to go ahead and deploy their machine learning solutions on the platform. So now let me go ahead and show you how that works on the platform and how data scientists can deploy their machine learning models. So I've talked about Model Hub here, right? So if you remember the first, the home page that I've talked about, on the left-hand side, you see various features. Here you have Model Hub. So this is where we have all the machine learning models deployed. So these are all the machine learning models that are currently deployed on clusters. And these are all live machine learning models that can be evaluated by anyone and that can be looked upon by researchers, companies, startups. Anyone who's interested to go ahead and look at machine learning solutions can look at these models. So these are all the machine learning models that the community has already deployed on the platform. And these models are typically categorized into 5 different spaces. So first is structured data prediction models. That is, if you have your data in the tabular format, either in Excel, CSV files or any database, and you'd want to create a machine learning model that would predict a particular element based on the other variables. So that is where you have structured data predictions. That is, you know what is your prediction element. For example, let's say you're trying to predict Y, and you have various features like X1, X2, X3, X4 on which your Y depends on. So that is where structured data predictions become relevant. So for example, if I want to predict sales of a particular organization based on several factors, like what is the price of the product, what is the footfall of the customers, so on and so forth, right? So for those reasons, Y will be my prediction value, that is here the sales, and X will be other values. So that would be structured data predictions. Image classification. That is where your input is an image and output is a text. That is, if you train your machine learning model to identify certain classes, so for example, someone wearing a mask versus someone not wearing a mask, then that falls in the category of image classification. So that is another kind of model that we support on clusters. That is, if you, again, it's just not binary classification, it could be multi-class classification also. That there is no limit on number of classes that you are training your model on. So the whole idea is, when someone needs to evaluate this model or see how this model works, all they have to do is provide an image as an input, and you would be getting a text as an output. So that is a image classification model. And now comes object detection. In the object detection model, you have input as an image and output is also an image, but obviously with the objects which are detected, the boxes drawn around the objects that are detected in that particular given image. So that is your object detection model, where input is an image, output is an image. Now, text classification model. If you have trained your model to identify what category a particular text document could belong to, so that's typically referred to as a text classification model. That is, you have multiple classes under which you can categorize your text data into. So that is where the input is text that is provided by the user, and output is also text that talks about which class that your model or your text input belongs to. Similarly, we have entity recognition. That is again an NLP model, where you have input provided in the form of text and output also in the form of text. But the only difference is in this case, the model recognizes various entities that are there in that particular text input. So the entities could be people, it could be places, it could be anything. Any custom entity also is supported that you would want to build your model to understand. So these are various forms of models that are supported on clusters for deployment. And you can train your model to do anything in the boundaries of these kinds of model templates. Now, let me look at some of the models and show you how the model looks like and what do we really mean by deploying a machine learning model on clusters. So the first model that I'm going to show you is this particular model. So this particular model has been uploaded by a person by the name Shailesh. So if you look at this particular model, here you will see first the model overview. So this person has built this model, which is yoga pose detection using MediaPipe. Now, in the model overview, the person provided the entire details about what this model is, how does it do what it does, and also he has provided certain code inputs with respect to how the code typically works, and he has explained the code also. Now, this is just the descriptive the descriptive part of the model. Now, let's see the model in action. So that is where your deployment comes in. If you go to deployment, you will see here that there is an inference URL that has been created for this particular model. If you click on this particular URL, you will see a microsite created for this person for his model called as yoga pose detection using MediaPipe. For this model, this microsite has been created. Now, what this person needs to do is he can go ahead and give some sample data so that the public can look at that sample data and use the model and see how the output looks like. Or else you instead of using this person's data, you can directly use any image that you want to upload from open web. Let's say if you are going to Google and this model says it detects yoga poses, right? You download some random yoga pose and give it to the model and see how it works. So now let me just give an input and show you how it works. So let me just select one image, click on I'm not a robot, and submit. So in the backend, what Clusters is doing is it's recreating the entire model environment, and it's going to give this as an input to the model, this image, and now this has been detected to be a mountain pose. So this is how the person has built this model that gives you, it takes an image as an output, gives an image as an, it takes an image as an input, it gives you an image as an output, where he has also superimposed the class of that particular image on the input image itself, and he has shown it in the output. So that is how all the models that are deployed on clusters can be looked upon by any fellow data scientist or startups or companies who would want to go ahead and use these models, and then they can use this solution on clusters. Okay, so this is how this particular model works. And I'm also going to show you certain other classes of models. For example, this particular person has built a forest fire detection model. Again, he has his own URL. You go here, you upload an image, and you see here, this is the output. This is the input image that I've already given. This is the output. Now, here in this case, the input is an image and output is text. That is, again, the text is something that the data scientist has already stitched together from the model's inference output. Okay, so here he said fire detected, confidence is so much. So this is something that the person has provided while building the model. So this is for the another kind of a classification. So this is the image classification model. Now let's look at structured data model. In the structured data model, input is a CSV file. Output is also a CSV file. For example, this person has built a model called as breast cancer detection. And this is how the input file looks like. If you go to sample test data, her input sample file looks like this. Where this is there are various parameters. And once you give this as an input file, model looks at all these parameters, and based on that, it gives you a prediction file that can be downloaded. So if you see here, right, on the model screen, Clusters has shown that predictions are downloaded in CSV file, and you'll see the file automatically downloaded to your local desktop. So that's where you can see the predictions. So for example, here, this is the way in which the person has provided the output. Okay, so this is the way the output is shown to the user. So that is a structured data prediction. Now there are text models also, NLP models. So for example, if you look at this kind of a model, right? So this is entity recognition model for identifying diseases in any given text. So here is a input that can be given, and when someone clicks on submit, the output is the diseases present in the given sentences are hypertension, diabetes, tumor, and metabolic defect. So these are all the entities that are detected by this person's model. So this is how you provide various models on Clusters. You upload them, and the Clusters as a platform stitches this microsite for free for all the models that are provided on the platform. So that is how your machine learning models could be evaluated by anyone, and that is where your research becomes very, very prominent. So this is how the model repository works. Now let me also show you how do you deploy a model on Clusters. So guys, you need to understand how the deployment works, what is Model Hub and everything, because the internship hackathon that we are going to conduct is for recruiting research interns who can actually build quality machine learning solutions that solve real world problems. So for those reasons, this webinar is going to be really instrumental for you to understand what is Clusters, what is Model Hub, how do you deploy models on Model Hub. So for those reasons, you need to understand this part very clearly. So now I'll also show you the guidelines. So how you can go ahead and upload a solution on Clusters. So one of the major things that you would require to upload your own machine learning model on Clusters is something called as an inference.zip file. So what does the inference.zip file need? So if you are trying to build a machine learning model and deploy it on Clusters, you would need a file called as inference.zip. And what are the contents of that file is something that I'm going to talk about now. So the inference.zip file folder structure contains these 3 files and any other supporting files or folders that you'd want to use. So for example, let me start with requirements.txt. Requirements.txt is a document where all your model libraries are present there. So what are the libraries that your model would require? Again, by the way, entire platform works on Python as an inference framework. So for those reasons, requirements.txt would need to have all the Python libraries that are necessary for you to create your machine learning solution. So these are the same set of libraries that you yourself have used for building your machine learning model. So that is the requirements.txt. So how does it look like? So it looks like this. You provide a requirements.txt with all the libraries that you have used for model training and model inference. So those libraries needs to be provided here in the requirements.txt. And guys, we strongly suggest you guys go ahead and create a virtual environment in your local laptop, or let's say you're doing it in Colab. You create a separate virtual environment where you build your machine learning model, deploy it and see how it is working, and then provide requirements.txt on Clusters. Otherwise, what would typically happen is if you do requirements.txt manually, then you could miss out on certain libraries which are important. So for those reasons, we suggest you to automatically create requirement.txt document. If you are already into data science, most of you would already know how to create requirements.txt document, or else we have a detailed document on Clusters model homepage here, deployment guide. You go here, this guide will tell you how to create a virtual environment in your local. This guide will also tell you how to create requirements.txt document. All those things are provided in the model deployment guide. So, but the idea is you have to first provide requirements.txt file, then followed by the trained model file. So whatever model that you've already trained, it could be a H5 model, it could be a pickle file, it could be any kind of a model that is already trained. You need to provide that trained model as a file. And finally, you need to provide inference.py. This is where your inference code lies. So how does an inference.py file look like? It typically follows this kind of a structure. It starts with all the import statements that are required for your model inference to work, followed by any one-time executable operations. For example, you might want to load the model, you might want to do label encoding. All those things are provided after this. Then you write a function called as predict. You define a function called as predict and give some input arguments, and followed by this entire predict function. So what does a predict function typically have? You can have data pre-processing in it. You can have inference, actual inference. That is, whenever there is an input given, your model is going to predict, right? So that's the actual inference. And then you can have a return function, return functionality, where this particular function would return the output based on the use case. So we have seen various use cases, right? So if it's an NLP model, input is text, output is text. If it's a object detection model, input is image, output is image. So like that, there are various output formats in which you can return the output. So that is what is shown in the output here. So guys, this is a sample inference file. You have all your import statements first, followed by your class definitions, then followed by loading the model. So this model is the same model that you have provided here. You have to load that particular model first, and then define a predict function. You should not change this terminology, guys. You should have predict only as a function name, and then provide input as image underscore path. And then you can do whatever you want here. So that is, you can do whatever type of pre-processing that you want to do, or you can do whatever kind of image augmentation techniques that you want to use. All those things you can provide here. And then once you're done with that, your actual prediction. So for example, here model.predict of the given input image. So that is the image, the given input image. Now, once that part is done, you can go ahead and process the output also if required, and then send back the output like this. So for example, in this case, we are looking at an image classification model. So input here is an image. So since we are going to deploy this model for you, you don't give any particular image here. Just give the path, just a placeholder called as image underscore path, and then use that image underscore path for whatever actions that you want to in your predict function, and then give that as an input to your predict function here, and then finally give the output as a for example, this is a text file, right? So text output, because image classification we have seen already here in image classification. This is the input, this is the output. So this is a text output, which is having a mixture of class. This, let's say this is the class, fire is the class. This is some string that the person wanted to convey. At the same time, this is also some string, and this is the accuracy that is returned by the model. So he has stitched all these together and passed it back as a text. So that is what is the output that we are talking about, and return that particular output. So this is inference file, this is requirements file, and we also need a train model file. So based on whatever use case that you're working on, this is the structure that you would follow. So this entire structure would remain the same. The only difference is based on your use case. Here input is an image, output is a text. In the case of object detection, input is an image, output is an image. So we have all the kind of examples for all the models. So for example, you can go ahead and look at here on clusters, right? So you see here deployment FAQs. We have a model for every kind of a solution. So you just need to go ahead and click on each of these. If you click on image classification, whatever I've shown you will open. If you click on object detection, another sample model will open. So this is how you go ahead and build your machine learning model and deploy it on clusters. So now that you have, okay, so now let's say this is how your structure would look like. Typically your folder structure would look like this, right? In your local environment, you will have requirements.txt that would look like this. you would have your trained model file, which could be a pickle file or h5 file or whatever file format that you are following. And this is your inference.py file. So where you have all the import functions, followed by loading your model, followed by, let's say, class encoding and predict function, where you are doing all these operations and returning an output. So this is your file format, inference.py. And this file inference.py format will depend on your use case. And you can look at model inference.py files for all the different use cases that we talked about, object detection, image classification, that are available on Clusters as a reference. Okay, so that is something that you can look at. So once you have all these three files, you can do two things. One is you can zip them and put it in a Google Drive and make that file a publicly accessible file and give that as an input, inference.zip input on Clusters. That is one way. Or else put all these files in a GitHub repository and give us and make it a public repository and give us the public repository link, GitHub public repository link on Clusters. So that's how you go ahead and deploy machine learning models on Clusters. So let me show you how that deployment also needs to be done. So the moment you go to the model homepage, here you see post a new model. Once you click on post a new model, there's a new page that opens where you'll have to mention all the details about your machine learning model. For example, what is the title? If there are any keywords, right? So for example, there could be keywords like computer vision, machine learning, whatever keywords you want to use for your model to be identified easily. So that is something that you can mention here, followed by commas. Then mention the category. For example, you're solving any specific problem in banking, healthcare, or anything, mention it as domain. Or else, let's say if you're not solving any domain-specific use case, let's say you're solving a problem like fire detection, right? In that case, it's a generic model. Mention any one of these. So let's say I'm mentioning banking. It will ask you for a subcategory. Sorry, I'm mentioning it as domain. So it's asking you for a subcategory. You can mention any of the subcategories. So for example, I'm mentioning banking. And give a short description of your model. So guys, short description of the model is something that goes here. So if you look at these models, right? So the short description of the model is on the actual model page. So this is where the short description is. Okay, and here you have model overview. Model overview is this. Actual models overview. This entire model overview. This is the model overview that you see. Then you provide any photo, main photo that you'd want your model to be tagged to. So that will be shown here in the model hub like this. These are the photographs. That's the pictures. Now enter the model category. For example, image classification. Now this is very important, where you provide the inference source location. So here in the inference source location, you need to provide the Google Drive link where your inference.zip file that we have discussed earlier is present, or else directly you can give a GitHub or public repository link here. There are two ways in which you can do this, either Google Drive or GitHub. And also provide test data location if you have any test data. So that once you provide test data location, it will be available here. On your model page, here you see sample data, right? It will be made available here. And you can also provide model accuracy and mention the model as either public or private. Commercial is not for you. It's more for startups or proprietary models. You can mention either of these and then click on submit. So once you click on submit, all these details are incorporated and a new model page is created for you. So for example, this is how the model page would look like, where you have all the model overview. And in the deployment section, you will see here deploy button. So this model is not yet deployed. You have just given the location where your inference files are. Now the moment you click deploy, that is where your model page is being created by Clusters. So that is where we create this entire page for you and produce this link automatically. So every model by a user would be given a link automatically. So that link will be provided to you once you click on deploy. So in the deployment, if there are any errors, let's say if you have missed a library or if there are any kind of errors, then you will see the error log here. You can click on it and you can download the error log and check what has gone wrong. And also, if you look at our deployment guide, in the deployment guide, we have also mentioned how other things that could be useful for deployment, like how do you create a virtual environment, how do you deploy a model, if there are errors on clusters platform, how do you debug those errors, and you can roll back the model also if you feel that the model is not great. If you want to rework on the model and again deploy it, you can roll back that particular model also. So once your model is deployed, you will get a rollback option. So right now this model is not deployed, so you're not seeing a rollback. But if the model is deployed successfully, you will see a link getting generated like this, and you will see a rollback option. So if you roll back, this page will be deleted and a new page will be created going forward. That is with your new model. So whatever changes to your model you want to make, you can make it here. Go back to the location where you have uploaded the model, change your model, and then roll back. And once you roll back, again deploy will be made available. You can again deploy. So guys, you will be given 5 attempts on the whole for deploying the machine learning models. If you can't deploy in 5 attempts, then you'll not be able to deploy anymore. Okay. So for those reasons, make sure if you are understanding how to deploy the model. Now, if you are finding any issues while deploying, or if you are finding any difficulties, you can reach out to us in 2 ways. One is here, there is Connect. Go to Connect, and here you can put title of whatever problem you're facing. And most importantly, select the category as Model Hub, severity as Hackathon query, and then submit it. Our team will revert back to you. That is one way. Or else you can also send us an email. I will talk about what is the email ID and how do you send it in a bit. But this is again a preferable mode of communication where you can post your hackathon query. If you're stuck anywhere or anything, you can mention it here. So that is how models are deployed on clusters. Okay, so that brings me to the next point. That is, we are now launching F1 Data Science Internship Hackathon, where a lot of participants have applied for this particular internship, right? So we are going to shortlist top 10 data scientists and give them paid internships, winner certificates, and also they get to be mentored by our team and also other fellow data scientists. And we also provide recruitment opportunities based on their profiles. So that is something that we have launched, and there is a procedure for participating in the hackathon. So what we do to evaluate your profiles is we shortlist your profiles based on the models that you deploy on clusters. So you need to follow a certain procedure for deploying a model on clusters and applying for the internship hackathon. So the first step that you need to do is apply for the internship on Cluzters.ai. So once you sign up on Cluzters.ai, you would be given an opportunity to, you can go to the jobs section there and you can apply for the internship. So also you will be shared the internship job link right now in the chat section, where you can go ahead and look at the internship link directly. Or else once you sign up on Clusters, you can go to the job section and in the search box, right, just type F1. This is F1 Data Science Internship, right? Search F1, you will find the internship listed there. And then go and apply for that internship. Only the candidates who apply for the internship through Clusters are eligible for participating in this internship hackathon. Then once you have posted your application on Clusters, the next step you need to do is select a good model use case in the area of healthcare, retail, banking, or whichever area you think you're solving a problem in, a real world problem, right? So that is where you need to go ahead and select a use case, very good use case for yourself. Guys, remember that this internship position that we are looking at is for a research intern. Okay, so for those reasons, you should be able to do proper research, come up with some pain point, and you need to come up with a kind of a machine learning model that solves that particular problem. For reference, you can also look at the current models that are there on Clusters platform already. Then once you've selected your use case, then you go ahead and post your model. I've told you, right? So you can go ahead now and post your model here. So I've shown you how to do that. So here there's a post a new model link. You go ahead and mention all the model details and post it there, and your model will get approved based on the use case. Once your model gets approved, then you are in the race. That is, your model is now approved and you can deploy the model. So your model is approved for deployment now. So the moment the model is approved, you will see this kind of a deploy button on your model page. So you have to go to the deployment tab here. So you understand these things, right? So model overview is where I'll just show you through another model. Let me just show you through this. So model overview is where you enter the model's overview yourself, and deployment is where this link from cluster side would be created. And if you are owner of this model and your model is approved, you'll see a deployment button here. So I've shown you the deployment button earlier, right? You need to click on deploy, and the model files that are provided here would be taken into account, and we deploy your machine learning model and provide it as a output here in the form of a link. And also you can start discussions on other models. You can upload any photographs if you would want to for this particular modeling solution. You can upload any videos, tag any videos here. In the vault section, you can tag any documents. You can upload any documents that you find would be relevant. And also reviews would be something that the community will provide based on your models. These are the reviews that the community will provide on your models. So that is how this page looks like. So now, once your model is approved, in the deployment tab, just check here, you will be seeing a deploy button here. You click on deploy button, this link will be generated. If there are any errors, you will see an error log getting shown here. So that is how you deploy a model, right? So going back here. So now once your model is deployed, go ahead and deploy your model on Model Hub and make sure your model is use case is well documented. I've shown you how the overview should actually look like, right? Then understand that your data should be sufficient. Okay, we are talking about solving real world problems here, guys. So you should have relevant data points. If you don't have relevant data points, or if the data is limited, or let's say if you don't know what are the features. For example, I've seen data sets where the column names are hidden. So let's say you have Y that you are predicting, and the column names, instead of providing the actual column names, they provide the column names in the coded fashion, like X1, X2, X3, X4. So those kind of features are not really relevant. So for those reasons, you'll have to mention the data that is really understandable and easily available, and the volume also is sufficient. So pick up such kind of a use case where you have enough data available in the public domain. So once you do that, then our team goes through all the models that are deployed and selects the top 10 models and automatically generates the internship letters for them. Okay. Now there are certain hackathon guidelines that you need to follow. So for every use case that you're going to submit, you need to first understand what is the real problem that you're solving, who can use it. For example, let's say if there is a food review model that someone is trying to build, so companies like Zomato, Swiggy can use it, right? So you need to mention who can use that model, and then describe your solution properly. That is, what is the data source, and describe the data. Okay. So for example, let's say you have a lot of classes in your data. So class A has so many data points, class B has so many data points. Describe your data properly. Then provide whatever pre-processing steps you have followed on the model. So provide all the data pre-processing steps that you have followed. Then if you have evaluated multiple models, you talk about what are the various models you've evaluated and which final model is being used. Okay. And when you're using the model, when you're mentioning the model that is being used, clearly mention step-by-step process of building that particular model. And also if you've taken inputs from any articles, please mention the references. And finally, describe the solution efficiency, where you have to mention not only just the accuracy, but also certain other things like F1 scores, RMSE, sensitivity, specificity, whatever you'd want to really mention that would give us more information on evaluating your model. So mention those things here. And currently, we support these type of tasks: image classification, object detection, text classification or topic modeling, entity recognition, and structured data predictions, both numerical as well as categorical predictions. So these are the rules that you need to follow. And the guidelines that we would use to evaluate your solutions are, we would check if the relevance of your use case is really profound. That is, if you are solving a real world problem or not. And then we would look at the quality of data set that you have used, sophistication of your solution, how well you have structured your solution, and what kind of models you have used. And then we'll also look at your accuracy scores. And finally, we will also look at the quality of documentation that you have provided on clusters. So based on all of these factors, we understand how good you are at data science research. And based on that, we are going to go ahead and generate internship letters for the top 10 candidates. So this would be a paid internship letters. And certain important dates that you need to keep in mind is we are already done with the webinar today. So on 10th of September, we have launched this particular cohort, and the start date for the event would be starting tomorrow, that is 11th September, and end date would be 9th September midnight. So guys, in no circumstances this would be extended. It is 9th September 2021 because our data science panel needs to have certain buffer to evaluate the solutions, and we are going to announce the cohort 1 by 25th September 2021. So this is going to go on all our social media handles, and also we are going to generate offer letters and we are going to onboard you subsequently. So that's something that you need to really understand. And also guys, while signing up on Clusters, if you do not have prior data science work experience, while signing up, just sign up as an enthusiast. Don't sign up as a data scientist, because if you sign up as a data scientist, your profile might be rejected if you are not having data science experience. But if you have gone through some official training somewhere, or you already worked a couple of years as data scientist somewhere, you can mention as data scientist. You can also mention as data scientist if you have taken any official training, guys. Okay, so if you have taken any training with a reputed institute, you can mention your profile as a data scientist. But otherwise, you have to mention it as enthusiast and provide all the details and just sign up. And once you sign up, go to the opportunities section here on Clusters page, and then go to the browse jobs section. This is where you can go ahead and search for F1. This is a F1 internship. Go to the F1 internship and you can start applying. So once you go here, you will see an apply now button. Since I'm not logged in here, I'm not seeing apply now, but you will see an apply now button. Please click on apply now. That is when your participation will be officially counted. Then once you're done with it, go to the model hub and check all the models that are already available. That will give you a very good idea on what kind of modeling solutions exist. And also check the deployment guide, guys. I understand you are listening all of these things for the first time. It might look a bit overwhelming. For those reasons, go ahead and look at the deployment guide first, and then go ahead and start and attempt your new model. So once the model is approved, you will be approved for deployment, and within all the deployed models, the top 10 solutions would be selected for internship. So that's the whole process that we are going to follow. So that's it from my end, guys. I wish you all the best for the internship hackathon, and we would really want to work with bright minds of next generation data scientists, and that's where we have started this entire exercise. If you have any questions, you can always reach out to us through either the portal, through the connect option, or else you can send us a mail at info@cluzters.ai and have the subject as internship query. Okay, so this is very important. Make sure you mention this as an internship query, the subject, or else we'll be missing your emails. Okay, so that's all I wanted to talk about as part of today's webinar. Now we will open the round for Q&A, and then we can you guys can go back and start preparing for the internship hackathon and submitting your solutions.
Thanks, Jay, for clarifying the internship process and how they need to submit the models and so on. So guys, we'll be sharing the recording of this session with you soon, so that you can use this as a reference when you work on your models, as well as when you deploy your models in Cluzters.ai. So in case if you have very specific questions with respect to internship that you want to clarify right now, so you can ask us. Or if you have some questions while you're working on the models and so on, like Jay said, you can send us an email so that we can revert back to you. Whoever have questions, right, you can put it in the chat Q&A box right now, so that we can answer a few questions now. Jay, looks like we have a couple of questions, so I can take this. So I did internship in Sparks Foundation. Can I honor myself as a data scientist? Yeah, so let's say if you have done data science internships before from a reputed company, right, you can choose yourself as data scientist on the platform and then fill up your profile. if you guys do not have any more questions, we'll stop the session now. We'll share the recording of the session with you guys via an email. Refer to the recording and try to sign up on Cluzters.ai and apply for the internship that Jay has talked about, and then work on your model. Try to submit the model before 19th of September so that we can consider your model for the selection. And we'll announce the results on 25th of September, whoever has been selected for the internship. And we'll periodically send you the reminders as well as the updates if you have extended the timelines and all. So you will receive continuous updates from us via an email. All the best, guys. If you have any questions, do send us via an email. We'll revert back to you.
Pradeep, I think there are a
Thank
couple
you,
of other
guys.
questions. So
Yeah.
Vatsal is asking, I've done single internship, should I select enthusiast or data scientist? So you can select data scientist. So guys, what would happen is if you select it, if you feel that your profile is eligible for a data scientist, please do select data scientist. Okay. So unless and until if it is not very relevant, we would not turn it back to enthusiast. So all the data scientist applications who do not qualify, we will anyways revert them back to a enthusiast. The difference between an enthusiast and data scientist on the platform is with respect to certain access features, but with respect to the internship hackathon, there's going to be no difference. Okay, so for those reasons, you can mention Vatsal, you can mention as data scientist and go ahead and apply. So next, we have another question. After shortlist, is there an interview selection or selection? No, Asim. After after your models are evaluated and once we have finalized your once your model is finalized as part of the shortlist, then there will be no further interview. You can go ahead and directly take the internship certificate from Cluzters and start working with us. Can we participate in teams? Swarna Vidya. So Swarna, so this is an internship hackathon, right? So if you feel that you and your team member can work together and create a really great solution, then please go ahead and do that. Okay. But again, I would ideally suggest you guys to work individually. But if you want to work as a team, please go ahead and do that. But again, once your model is shortlisted, we need to understand who has done what as part of your deployment. So for those reasons, there might be a next level of discussion with you guys if your model gets shortlisted. So that is where we'll understand what's your approach, and that based on that, we would offer internship to, let's say if you're working in a group of 2 or 3, all 3 of you, or only 1 of you, or only 2 of you. So that depends on what contribution each of the person has done. Next, what is the procedure for internship, like interview after 25th? No, Pawan, there is no interview after 25th. Once you're done with the hackathon and once we finalize your model to be part of the final shortlist, there is no further interview if your model is really good enough. Okay, so that is where we would go ahead and issue an internship offer letter automatically if your model becomes part of the top 10. Batula is asking, do we have to deploy code in Flask? No, you don't have to deploy any code here. You're not deploying any models, guys. So please understand that you're not deploying a model. You are just using an inference file. So I've shown you the structure of the inference file, right? Let me just again quickly show you that. You are just using a inference file. You are not really deploying a model anywhere. That is what we are doing on behalf of you. Okay, on Cluzters, that is what is being done. Okay, so you have to provide inference.py. So if you look at inference.py file, there is no deployment technology here. You're not using Flask, you're not using Gunicon, you're not using anything. You have to just provide a file in this format. So guys, you understand that whenever you're writing inference.py, so go ahead and write the file in such a way that you would do inference from your local. So for example, let's say I've shown you a model file here, right? So what do I typically do when I'm trying to do an inference in my local? I load my model, I have my class names, and once I load my model, then what do? I use model.predict function, right? And give an input. So that input is something that you give from your local laptop. Let's say there's a file in your local laptop, CSV file, you give that location, right? So that is how you write this inference file. You're not deploying this solution. You're just giving an inference code here. Say, what does the inference code have? Import libraries followed by loading of the model, and within predict function, actual predictions. You have to do all the pre-processing first, followed by predictions, post-processing, and then send back the return back the output. So I've talked about various kinds of outputs, right? Image, input image versus input output image. Input image versus output text. Input text versus output text. So all those things are already provided on clusters as reference models. Go ahead and look at them. So you're not deploying any model anywhere. You are just providing this piece of code as an inference file. We will deploy that solution for you. So on the page that you are looking at, the pages that we have talked about here, right? These pages. Sorry. So this page, this is where your model is deployed by us. So Clusters is doing the deployment for you. You have to just mention requirements file, your trained model, and inference.py. Only 3 things. If you have any more questions, guys, please refer to the model deployment guide. You will have most of your questions answered there. And also look at other models that are already deployed for you to understand how they have done it. And there is deployment section FAQs also. Please go through that also. You'll be able to understand. But still, if you are stuck somewhere, you're not able to go through, go to Connect and send us a note. Once you drop us a note here, please make sure you're selecting Model Hub, Category, and Hackathon as a query. So that's how we are going to answer your questions. So I hope that part is clear. So the next question is by Suraj. Do we have required data in Cluzters.ai site? Suraj, we do have a section called as Vault, where we have curated data sets from various sources. You can use that, or else you can go ahead and bring any data set that you'd want to. There are a lot of publicly available data sets these days. If you feel there is a very impactful data set that can be used for solving very specific problem in through machine learning, please feel free to use any data set. Is Jupyter Notebook, IPython Notebook allowed to upload? Bandhavi, no. We don't allow Jupyter Notebooks to be uploaded. You'll have to create a Python file. Okay, you need to create a Python file. The format, I've told you the format, right? It should be exactly the same format. So if you are having any questions with respect to format, please go ahead and look at the deployment guide. You can't upload a Python notebook. Is the Swarna is asking, is the course available in Clusters paid? No, we don't offer any courses ourselves, Swarna. So those are all curated for you to understand what are the various types of courses available in the data science and AI space. Those are linked to some external sites. Those are curated by our own community members. So you please go ahead and look at it. So we don't have any control on it. It is just based on community curation. So a lot of people post a lot of courses and stuff that they come across which they feel are relevant. Prabhakar is asking, can I select anything related to agriculture domain like satellite image to classify? Absolutely, Prabhakar. We would love to see certain things in satellite imagery space. In fact, we are working with Telangana state government right now to provide good solutions in the AI space. So if you are working in the agriculture space, then definitely it's a very good area to work in. Patula is asking, if any of the top 10 have not joined the internship, then the next person can get a chance, or else only top 10. No, there will be a rolling chance for the others also, but typically that's not the case. But in case if someone is for some reason not able to join, then yeah, the other person or the next in line person would be given an internship certificate. Okay, so if you have any more questions, I can take it, or else you can always reach out to us through email or through our platform, and we will be happy to answer your questions and assist you. Once you are done, and once we have shortlisted you for the internship, you will be put into your respective teams. So let's say you have built a computer vision model, you'll be working under a certain team lead. If you have built a NLP model, you'll be working under another team lead, so on and so forth. So it will be a great opportunity for you to learn and grow yourself. And I'm hoping to see a healthy participation from everyone in this webinar, and also people who are not able to attend the webinar, we'll be passing the recording. Once they go through it, I hope it will give them more clarity with respect to how they can participate. Okay, guys. So If you don't have any further questions, okay. So Swarna is asking, how do you evaluate enthusiast versus data scientist? So Swarna, that mechanism is something that is completely up to us. So if we feel that you have enough data science knowledge to be called as a data scientist, let's say you have been trained with a good institute, or you have already done an internship somewhere, or you have graduated in a discipline where you have majors as data science. I mean, there are a lot of other factors that are involved as well. So that is something that we take into account to understand whether your profile qualifies for a data scientist. But guys, if you feel that your profile really qualifies for a data scientist, I would still strongly encourage you to go ahead and sign up yourself as a data scientist. In the worst case, what could happen is we would look at your profile and give you a temporary access as an enthusiast. But later on, once you are done with the, again, by the way, all the people who are done with the internships are automatically upgraded to a data scientist. Okay. And also people who have provided the machine learning models, working machine learning models, and approved machine learning models on clusters are also automatically taken as data scientists. Okay. They're upgraded automatically. Okay. So that is something that you can keep in mind. Dhirendra is asking, can I work on electronics model like PCB detection? So Dhirendra, as long as it falls in the categories that we have talked about, image classification, object detection, text related models, or structured data models, you can always do that. So it would be really interesting to see very specific problems being solved in various industries, but make sure you're understanding what is possible, what is not possible on clusters by going through the deployment guide first. Okay. Swarna is asking, apart from internship, if I'm not selected, can I try upload my models by being connected with Clusters platform? Of course, it's a public platform, Swarna. So you can always do that. And also, guys, if someone is not selected this time in the top 10, don't worry. We do this every quarter. And once we see active participation from you on the platform, we would definitely offer a internship ourselves. So we also want to work with good, enthusiastic data scientists. So that is something that you need to keep in mind. The journey doesn't end here. So in fact, if you go ahead and upload relevant solutions moving forward also, right, even though you're not selected, there are high chances that we will even call you for an interim internship even before the next quarter starts, provided your models are really good. Okay, so for those reasons, you can always do that. And also, someone has asked, can I upload multiple solutions? Yes, you can upload multiple models. Best of the models will be considered for evaluation as part of the internship hackathon. Okay, guys, any more questions? Fine. So if you don't have any more questions, so Snegar is asking, can I do this internship as part-time since I'm studying? Yes, Snegar, but again, you'll have to reach once you're selected for the internship, you'll be given targets. For example, you'll have to really work on research on machine learning models, and you'll be guided by industry experts and data scientists, of course, but you'll have to work on certain deadlines, certain timelines. If you can manage your studies along with this, then you are more than welcome. You can definitely do that. It's not necessary that you do this full time, but you should meet the deadlines. Then deadlines will be very strict, guys. So even after you're selected, and if you don't meet the deadlines, there'll be 2 strikes given. After the second strike, your internship would actually be paused or cancelled. So for those reasons, I would suggest you spare some good amount of time before really applying for the internship. Okay, so that's all, guys. Fine. Then it's about time, guys. So let me wrap up the webinar today. You can always reach out if you have more questions. Please reach out to us through either Platform Connect or through email, and we will be replying back to your questions. Okay. Thank you so much for taking time out and listening to us in this webinar. And all the very best to all the participants. And I hope to work with most of you going forward. So that's it from my end. Thank you. Thank you so much.